Question 1. Part A. Work out the value of 25 minus the square root of 43.87, all divided by 6 plus 2.1 squared. Write down all the figures on your calculator display. Right, so off to the calculator. And so on the calculator, we want to be really careful typing this in. So if we hit our fraction button on the numerator, we've got 25 minus the square root of 43.87. Click down for the denominator, 6 plus 2.1 squared. So making sure we've got that in correctly, hit equals, and then we can write down all these values on our display. And there we go. Part B, work out the value of the reciprocal of 0.625. So the key thing here to remember is reciprocal means 1 over. So again, on our calculator, we can do 1 divided by 0.625, and we get an answer of 1.6. Question 2. Write 60 as a product of its prime factors. So I like to do this prime decomposition using factor trees. And so how you do that is you start with your number that you want to write as prime factors, so in this case 60, and I want to find two factors. I typically like to start with 2. If we can divide it by 2, which is the first prime number, it's normally a nice number to see if we can divide by, and then a relatively simple number to divide by as well. So 2 lots of 30 makes 60. And so this being a prime number is the end of this branch, if you like. So now we look at 30. And again, I like to divide by 2 if I can. And I can see here, this is 2 lots of 15. Of course, you might have done 3 lots of 10. And then 15 is not divisible by 2, so the next prime number is 3. Yes, it does divide by 3, 3 5s. And so writing 60 as a product of prime factors, that is to say 2 times 2 times 3 times 5, or 2 squared times 3 times 5. Question 3. There are 48 counters in a bag. There are only red counters and blue counters in the bag. The number of red counters to the number of blue counters is in the ratio 1 to 2. Helen has to work out how many red counters are in the bag. She says, there are 24 red counters in the bag because 1 is half of 2 and 24 is half of 48. Is Helen correct? And you must give a reason for your answer. Well, if 24 of the counters are red, then there are 2 times 24, which is 48 blue counters. But if there are 48 blue counters, then that's going to exceed the number of counters in the bag. So is Helen correct? No. If there are 24 red, there would be 48 blue, which would be a total of 72. Question 4. N is an integer, greater than or equal to -2 and less than 5. Part A, write down the greatest possible value of n. And so, as it's an integer, it is a whole number. It is not equal to 5, and so the greatest value is 4. Part B, on the number line below, show the inequality -4 is less than or equal to m, which is less than 1. And so at -4 on our number line here, we want a shaded circle. And the reason it's a shaded circle is because m can be greater than and equal to this -4. At 1, m is strictly less than it. So at 1, you just want an empty circle. You then want to join these with a line. And so this represents the inequality greater than or equal to -4, but less than 1. Part C, solve 2/5 of g minus 4 is less than 6. So we can solve this like we would any equation. We can add 4 to both sides. And so 2/5 of g is less than 10. And now dividing by 2/5, which is the same as multiplying by 5 and then dividing by 2. And so multiplying by 5, 2g is less than 50. And now if we divide both sides by 2, g is less than 25. Question 5. Here is a triangle and a rectangle. All measurements are in centimetres. The area of the triangle is 10 centimetre squares greater than the area of the rectangle. Work out the value of x. Okay, well, the area of a triangle is half times base times height. The area of a rectangle is length times width. And since the triangle is 10 centimetres greater than the rectangle, I'm adding 10 onto the rectangle. And so this is going to be the basis of my equation. And so using the triangle, that's half times 8 times 6x. And the length times width is 5 times 4x minus 1 plus that 10. Now if we start to simplify this, a half times 8 is 4 times 6, which is 24x. And then expanding the brackets here, 5 times 4x is 20x. 5 times minus 1 is minus 5 plus the 10. Now subtract 20x from both sides here, leaves me with 4x, which is equal to 5. And so dividing now by 4, x must be equal to 1.25. Question 6. Last year, a family recycled 800 kilograms of household waste. 57% of this waste was paper and glass. The weight of paper recycled to the weight of glass recycled is in the ratio 12:7. Calculate the weight of glass the family recycled. So first of all then, 57% of this waste is paper and glass. So we need to find 57% of 800. Now this is a calculator paper, and so 57% is 0.57. If I do 0.57 times 800, we get 456. So 456 is the amount of waste which is paper and glass. And this needs to split into the ratio 12:7. So 12 add 7 is 19. We have 19 parts here. And so 456 divided by this 19 is equal to 24. That means each part of this ratio is worth 24. Now I want the weight of glass. Glass is 7 parts, and so 7 times 24 gives me the amount of kilograms of glass. And again on my calculator, 7 times 24 is 168. Question 7. A number D is rounded to one decimal place and the result is 12.7. Complete the error interval for D. So what we need to do here is, starting at 12.7, let's find the number one decimal place below and above. And so since one decimal place is 1/10, we need to look 1/10 below this number, which is 12.6, and a tenth above, which is 12.8. Now the error interval is the midpoints of these numbers. And so the midpoint of 12.6 and 12.7 is 12.65. And the midpoint of 12.7 and 12.8 is 12.75. And so these values are the bounds of my error interval, which means D can be greater than or equal to 12.65, as a 5 will round up, and strictly less than 12.75. Because since a 5 would round up, we don't really want to include that value. Question 8. Tamsin buys a house with a value of £150,000. The value of Tamsin's house increases by 4% each year. Rachel buys a house with a value of £160,000. The value of Rachel's house increases by 1.5% each year. At the end of 2 years, whose house has the greater value? You must show how you get your answer. So let's start with Tamsin. We have a compound interest formula, which is worth remembering. The compound interest formula, the starting value, which in this case is 150,000, times the multiplier. Now the multiplier is the decimal that you multiply a number by in order to increase or decrease it by a given percentage. And so in this case, an increase of 4% would be finding 104% of the value of the house, which as a decimal is 1.04. So this 1.04 is the multiplier to increase by 4%. Now this is squared because I'm looking for the end of 2 years. So we have our starting value, our multiplier, and the number of years this is running for, and putting this into a calculator, we get the value of 162,240. Now let's do the same for Rachel's house. Rachel's starting value is 160,000. Her percentage increase each year is 1.5%, and so the multiplier is 1.015, and again it is to the power 2 because it is 2 years. And this evaluates to 164,836. Clearly, 164,836 is greater than 162,240, and so Rachel's house has the greater value. Question 9. The cumulative frequency table gives information about the ages of 80 people working for a company. Part A. On the grid opposite, draw a cumulative frequency graph for this information. Now when you plot a cumulative frequency graph, you plot at the end of the group. So at 30, I want to plot a frequency of 20. And so 30 up to 20. Then I've got 40, I want to go up to 48. Now the scale on this axis is one little square is one value, so it's a nice count up to 48. 50, I want to go up to 64. At 60, I want to go to 75. And then at 70, I want to go up to 80. Now I can join these with either a loose curve or straight lines. And we're done. Part B, I want to use my graph to find an estimate for the median age. Now the median age is halfway through the cumulative frequency. And so I can do 80 divided by 2 or 80 times 0.5, which is 40. And so at the value of 40 on the y-axis here for cumulative frequency, I'm going to draw a horizontal line across to my cumulative frequency graph. And then from that value where it meets, I'm going to draw a vertical line down to read this value off the x-axis. And here I'm at roughly 37. And so my estimate for the median age is 37 years. Question 10. A biased dice is thrown 60 times. The table shows information about the number that the dice lands on each time. Gethin throws the dice twice. Part A, work out an estimate for the probability that the dice will land on 6 both times. Well, the probability that it lands on a 6, given this experiment here, is 15 over 60. And that probability will be the same for 2 throws. So an estimate of the probability would be 15 over 60 times 15 over 60, which we can evaluate on a calculator to be 225 over 3,600. Sally is going to throw the same dice n times and record the number it lands on each time. She will use her results to work out a more reliable estimate for the probability in part A. Part B, what can you say about the value of n? Well, with experimental probability, you can improve your results or make them more reliable by doing it more times. And so this value of n must be greater than the 60 times it was originally thrown. And so the value of n will need to be greater than 60. Question 11. Use algebra to solve the simultaneous equations 2x plus 6y is 5 and 3x minus 4y is minus 12. So if we label these equation 1 and 2, and so we want the same coefficients of either x or y, let's get the same coefficient of x by multiplying number 1 equation by 3. So 6x plus 18y is equal to 15, And so then to get 6x here, if we multiply equation 2 by 2, that's 6x minus 8y is equal to minus 24. Now, if we subtract this bottom equation from the top equation, the 6x's will cancel. 18y minus 8y is 26y. 15 minus 24 is 39. Dividing both sides by 26, y is equal to 1.5. Now I've got my value of y. I can substitute it into one of my equations. Let's use equation 1. And so 2x plus 6 times 1.5, which is 9, is equal to 5. Subtracting 9 from both sides, 2x is equal to minus 4. And then dividing by 2, x is equal to minus 2. So my x value is minus 2, and my y value is 1.5. Question 12. The points A, B, C and D lie on a circle, centre O. ABCD is a rectangle, where AB is 8 centimetres and BC is 10 centimetres. Work out the circumference of the circle. Give your answer correct to 3 significant figures. Well, in order to find the circumference of this circle then, I need the radius or the diameter. I can find the radius here if I just draw a right angle triangle. So if I join O to B and O to the midpoint of BC here, I've got a right angle triangle where the distance O to B is the radius of my circle. Now this value is 5 and this value is 4, and so using Pythagoras, r squared is equal to 4 squared plus 5 squared. That is 16 plus 25, which is 41, which means r must be the square root of 41. Now the circumference of my circle is pi times diameter. The diameter is 2 times my radius, and so the circumference is pi times 2 root 41. And this is a calculator paper. Evaluating this, you get 40.232 and so on. My answer should be to 3 significant figures, which would be 40.2 centimetres. Question 13. ABC is a triangle. Calculate the size of angle BAC and give your answer correct to 1 decimal place. Well, BAC is this angle here. I'll label X that I want to find. Now, currently the information I have in this triangle doesn't help me find X. But if we notice here, I've got an 18 opposite this angle 70, and I've got this 15 which is opposite this angle I've labelled Y. And so I could use the sine rule in order to find the value of Y. And if I had the value of Y, then I can use the fact that angles in a triangle add up to 180. And so using the sine rule then, sine Y divided by 15 is equal to sine of 70 divided by 18. Multiplying both sides here by 15. And so on the calculator, we want to do 15 sine 70, and that's all divided by 18. This gives us our value of sine Y. To find Y, I want to do shift sine to the -1 of that answer, which would give me a Y value of 51.54 and so on. And so then to find X, that is 180 minus 70 minus this 51.54 and so on, which is 58.45. Now, since I want this correct to 1 decimal place, then this 4 will round up since the number next to it is a 5. And so to 1 decimal place, the answer is 58.5. Question 14. Show that x squared minus x minus 6 over 2x squared minus 5x minus 3 can be written in the form ax plus b over cx plus d, where a, b, c and d are integers. Well, the way to start this is to factorise the numerator and the denominator. And so on the numerator, I want two numbers which sum to -1 but have a product of -6. Now, -3 times 2 is -6, and -3 plus 2 is -1. And so on the numerator, this factorizes to x minus 3 and x plus 2. Now, to factorize the denominator, there is a good chance that one of the factors of the denominator will match the numerator. Now, of course, of the factors on the numerator, x plus 2 can't be a factor of 2x squared minus 5x minus 3, but x minus 3 certainly could be. And checking x minus 3, this would need to then be multiplied by 2x to get 2x squared and a 1 to get minus 3. And it does indeed then give a difference of minus 5x. Of course, you can use other methods to factorize this denominator should you wish. Now that I have factorized the numerator and the denominator, and I can see that this common factor of x minus 3, I can divide numerator and denominator by x minus 3 to leave me with x plus 2 over 2x plus 1, which is in the form that I want. Question 15. Here are the first 4 terms of a quadratic sequence. Find an expression in terms of n for the nth term of this sequence. Now, in order to find the nth term of a quadratic, the first thing we do is look for the difference between these values. And so we go from 3 to 9 is 6, 9 to 17 is 8, and 17 to 27 is 10. Now, there's always a second difference in a quadratic sequence. So looking again between 6 to 8 and 8 to 10, we have a second difference of 2. Now, this second difference you halve and put in front of n squared. So half of 2 is 1. So in this case, I know I'm looking at 1n squared, or just n squared. And so listing n squared, that is the square numbers 1, 4, 9, 16. I need to look at the difference from the sequence I have and this sequence of the square numbers. And so subtracting this n squared from the sequence we have, I would be left with, so 3 take away 1 is 2, 9 take away 4 is 5, 17 take away 9 is 8, and 27 take away 16 is 11. And so what I now need to do is find the nth term of this sequence, which I do by finding the common difference, which in this case is 3, and then finding the term before. So if this goes up by 3 each time, the term before would be to subtract 3, which would be minus 1. And so the nth term of this sequence is 3n minus 1. And so in total, my quadratic sequence is n squared plus this 3n minus 1, which is n squared plus 3n minus 1. Question 16. The histogram gives information about the number of hours some student used their phones last week. The histogram is incomplete. 28 students used their phones for between 30 and 40 hours, and 24 students used their phones between 40 and 60. Part A, use this information to complete the histogram. So firstly, let's write down the important equation for frequency density. Frequency density, which is my y-axis here, is the frequency divided by the class width. Now we have this first bit of information, 28 students, that would be the frequency, use their phones for between 30 to 40 hours. 30 to 40 is the class width of 10. And so we have the frequency of 28 divided by a class width of 10 means the frequency density for this bar is 2.8. Using this value, we can allocate a scale to this y-axis. And in fact, if this bar is at the height 2.8, then each little square is 0.1. And so I can label this as 1, 2, and 3. Now that I have my frequency density labeled on the y-axis, I can use this second bit of information to complete my last bar. 24 students used their phone between 40 and 60 between 40 and 60 is a class width of 20. So the frequency density is 24 divided by 20, which is 1.2. And so my bar between 40 and 60 needs to go up to 1.2. No student used their phone for more than 60 hours. Work out the total number of students. Well, the total number of students is the area of these bars added together, and the area of each of these bars is the class width times the frequency density. Now we have the frequency already for our final bar and our penultimate bar here, 30 to 40. We know that to be 28 and 24. And so we just need the area of these two bars. This bar here would be 10 times 3.6, which is 36. And this first bar would be 20 times 1.6, which is 32. And so the total number of students are these areas added together. 32 add 36 add 28 add 24, which is 120 students. Question 17. Part A, show that the equation x to the power 4 minus x squared minus 5 is equal to 0 can be written in the form x is equal to the 4th root of x squared plus 5. Now we're given a hint. Since we have the 4th root here, I want this x to the 4 by itself. So let's add x squared and 5 to both sides of this equation. And so x to the power 4 is equal to x squared plus 5. And now we want to take the 4th root of both sides. Taking the 4th root, x is equal to the 4th root of x squared plus 5, which is what we want to show. Part B, starting with x0 is 1.5, I want to use the iteration formula that x to the n plus 1, so that's the next term in a sequence, is equal to the 4th root of the previous term squared plus 5. And I'm asked to use this 3 times to find an estimate for a solution of this equation. Now, if x0 is 1.5, I find x1 by substituting x0 into it. That's the 4th root of 1.5 squared plus 5. And from here, I'll use a calculator. And so in an iterative formula question, if we put in x0, which is 1.5, then we can type in our iterative formula. Now we've got the 4th root, so the 4th root of xn, so that's our answer now, squared plus 5. And so hitting equals, that gives me the first iteration value, so that's x1. But I can now just keep hitting equals to get the next two. So hitting equals again gives me x2, and hitting equals again gives me x3. And we've been told to do that 3 times to find our estimate. And so my final answer is this 1.6697, and so on. Question 18. 2a to 5c is in the ratio 6 to 25, and 4b to 7c is in the ratio 20 to 21. Show that a plus b to b plus c is in the ratio 17 to 20. Well, using our equivalent fraction and ratio rule, I can write 2a to 5c being equal to 6 to 25 as 2a over 5c is equal to 6 over 25. Similarly, I can write 4b over 7c is equal to 20 over 21. Now, if I can write a in terms of c and b in terms of c, then I can add them together to get a ratio just in terms of c. So if I multiply both sides here by 5c and 25, that's 50a is equal to 30c. And now if I divide by 50, a is the same as 3/5 of c. Now let's write b in terms of c. So multiplying both sides by 7c and 21, that's 84b is equal to 140c. And dividing both sides by 84, b is 5/3 of c. Now I have a and b in terms of c. I can rewrite this ratio here. So a plus b is the same as 3/5 c plus 5/3 c. And that's to the ratio b which is 5/3 c plus c. If we add these together, we can show with common denominators, this is 9/15 of c plus 25/15 of c, and that is to 5/3 plus 1, 8/3 c. Simplifying this left-hand side then, that is 34/15. And if we write the right-hand side as 15ths as well, we can see it's 40/15c. Since with ratio we can multiply and divide both values by the same thing, we can divide by c here and then divide by 2/15 and see that this is equivalent to 17/20. Question 19. ABC is a right-angled triangle. AB is 9.3 centimetres to the nearest millimetre, and AC is 12.6 to the nearest millimetre. Calculate the lower bound for the size of the angle marked X, and you must show all your working. Well, if I want to find this angle in a right-angled triangle, I need to know if I'm using sine, cos, or tan. So we have 9.3, which is opposite my angle, and we have the longest side here opposite the right angle, which is the hypotenuse. And so we must be using sine in order to find our angle. Now, sine of our angle is equal to the opposite divided by the hypotenuse. In order for the opposite divided by the hypotenuse to be the lowest value it can be, then we need the lowest value that rounds to 9.3, but then we want to divide it by the greatest value, which rounds to 12.6. And so the lower bound for 9.3 is 9.25. The upper bound for 12.6 is 12.65. And so sine of my angle is 9.25 over 12.65 in order to find the lowest value, which on a calculator is 46.989 and so on. And so the answer is 46.989. Question 20. ORT is a triangle. O to T is vector A and R to T is the vector B. M is the point O to R such that O to M to R is in the ratio 2 to 3. And we want to express M to T in terms of A and B, giving our answer in its simplest form. Well, it would be useful if we had O to R, because if I have O to R, I can make use of this ratio. So O to R is A and then minus B. From that, we can find M to R. M to R then is 3/5 of O to R. Since O to R is split into 5 parts, O to M being 2 of them, M to R being 3 of them, then M to R is 3/5 of O to R. That means M to R is 3/5 of A minus B. Now we know how to get from M to R, we can get from M to T, because we can do M to R plus R to T. And so we've got 3/5 of A minus 3/5 of B, that's expanding this bracket here, plus R to T, which we know to be B. This rearranges to be 3/5 A plus 2/5 B. And so our answer, 3/5 A plus 2/5 B. Question 21. Here is the graph of y equals f of x. Part A, on the grid below, draw the graph of y is equal to f of x minus 4. And so we're looking at graph transformations here. And when we have the minus 4 on the outside of the brackets of this f of x, then this means it has moved down 4 in the y-axis. And so if we consider these points 0, 0, minus 1, 1, minus 2, 1, and minus 3, 0 on the graph of f of x, each of these will need to move 4 down in the y-axis. So that would be 0 minus 4, minus 1 minus 3, minus 2 minus 3, and minus 3 minus 4. Part B, on the grid below, draw the graph of y is equal to f of minus x. Now, when the minus is on the inside of the brackets, then this is a reflection in the y-axis. And so reflecting this shape in the y-axis, we have the following. Question 22. There are only blue pens and red pens in a box. The number of blue pens is 4 times the number of red pens. Rita takes a random 1 pen from the box. She records the colour of the pen and then replaces it in the box. She does this n times, where n is greater than or equal to 2. Write down an expression in terms of n for the probability that Rita gets a blue pen at least once and a red pen at least once. So to do this, we don't know how many pens we've got, but let's let x be the number of red pens. Well, then the number of blue pens is 4 times that. So 4x would be the number of blue pens, meaning altogether in our box, we have 5x pens. And so the probability of pulling a red pen out of our box is x over 5x, or 1/5. Similarly, the probability of pulling a blue pen from our box is 4/5. Given that we have the probability of getting a red pen or a blue pen, the case where Rita gets at least 1 blue pen and at least 1 red pen is 1 minus the probability they are either all red or all blue. Now the probability that they are all red is going to be 1/5 times 1/5 if she does it 2 times, times 1/5 if she pulls it 3 times. So it's 1/5 to the power n. Similarly, the probability that they were all blue would be 4/5 to the power n. And so there will be a probability of at least 1 red or blue, provided neither of these 2 events occur, which would be 1 minus those probabilities. And so in terms of n, 1 minus 1/5 to the power n minus 4/5 to the power n. Question 23. Here are 3 similar triangles, ABG, ACF and ADE. ABCD and AGFE are straight lines. The ratio of AB to BC to CD is 1 to 2 to 3. Show that the area of ABG to the area of BCFG to the area of CDEF is 1 to 8 to 27. So firstly, let's look at these lengths. Now AB, BC, CD are in the ratio 1 to 2 to 3. And so starting with our AB, A to B being 1 part, then if I look for A to C is going to be A to B parts plus B to C parts. That would be 1 plus 2, which would be 3. And then A to D would be A to B plus B to C plus C to D, which would be 6. Now, if these are the lengths of the sides of these triangles, or the ratio of the lengths of these triangles, then the area for the triangles ABG, ACF, ADE is going to be in the ratio of 1 squared to 3 squared to 6 squared. That's in the ratio 1 to 9 to 36. Now, starting with CDEF, this trapezium, that would be the area of ADE subtract the area of ACF. And so that would be 36 minus 9, which would be a part ratio of 27. Similarly, for BCFG, that would be ACF 9 minus ABG 1. And so that would be of ratio parts 8. And so the ratio of triangle ABG 1 to BCFG 8 to CDEF 27. So we have shown this. Question 24. The diagram shows 8 identical regular octagons joined to enclose a shaded shape. Each octagon has sides of length A. Find in terms of A an expression for the area of the shaded shape. Give your answer in the form p lots of 2 plus root 2 a squared, where p is an integer, and you must show all your working. So at first this looks like quite a daunting question. It's a very in-depth diagram. So we've got each octagon has sides length A. Now if the sides of each octagon are A, then the extra bit of information I would like is this distance here, which I'm going to call x. Now, although it looks to be a right angle triangle here, we can show this angle to be a right angle. We know the interior angle of a regular octagon. I need to do 180 divided by the number of sides times number of sides take away 2, which gives us a value of 135. Now, these three angles here together then need to add up to 360, and if these two are 135, then this angle is 360, take away 135, take away 135, which is indeed 90, and so we have got a right angle triangle. Now, this distance x can be found quite nicely, and so using Pythagoras, I can write x squared as a squared plus a squared. So x squared is equal to 2a squared, and x is then the square root of both sides here, so that would be root 2a. Now that I know this distance, the rest of this question actually isn't so bad. I would like to find the area of this large shaded square first of all. And so the large area of this square has side length a plus root 2a plus a. That is 2a plus our value for x. And we can now find the area of this large square by doing 2a plus root 2a squared. Now if we expand this, that is a squared, lots of, squaring this bracket here is 4 plus 2 lots of 2 root 2, which is 4 root 2, plus root 2 times root 2, which is 2. This bracket here we can simplify now to be 6 plus 4 root 2. So the square area is a squared lots of 6 plus 4 root 2. And the great thing about this is it's almost in the form that we want. Now, in addition to this large square, notice we have these 4 half squares on the edge. Now, if we were to join those halves together, those 4 half squares are the same as 2 squares, and those are squares of side length a, which means the area of those squares are a squared, and we have 2 of them. And so the total shaded area is the area of our large square, which we've shown to be a squared lots of 6 plus 4 root 2, plus 2 smaller squares, 2a squared. Taking the factor of a squared out of the 2a squared becomes a squared lots of 8 plus 4 root 2. And now I want it in this form here. Well, thankfully we have a factor of 4 that can be taken out of this bracket. And so it's the same as 4 lots of 2 plus root 2, a squared, which is what we want to show.